Hi everyone, welcome in. Thank you so much for joining today. We're going to go ahead and wait about 3 minutes to let the audience fill up, and then we'll get started. Okay, I think we've waited enough. With that said, good afternoon. Thank you all for joining. We really appreciate you being here. Welcome to this Kiuwan webinar, and we are so glad to have that you've taken the time today to learn about end-to-end application security and the opportunities enabled by the Kiuwan PreEmptive solution. We have an exciting event planned, including a test case for both of our solutions and some expert insight from JD and John, who are on the webinar right now. But let's get started by looking at the state of application security at the current time. The global application security market is expected to continue to grow, moving from 6.27 billion in 2020 to 7.67 billion in 2021, at an accelerating compound growth rate of 18.24%. It's not by chance that application security is growing at such a rapid rate. Companies across the globe are often completely reliant on their applications to deploy an effective customer experience, using them to manage service and customer engagement as well. So they are really critical to operational infrastructure for many businesses. But at the same time, organizations are really struggling to implement security, especially within their ever-changing agile development pipelines. Demand for security skills is projected to grow 164% over the next 5 years, according to a recent Business Wire report. It's likely that the lack of security expertise will significantly restrict the potential strength of application security approaches within organizations. The increased security breaches are really indicative of this, being one of the main factors that is driving the growth of this particular industry. But for many organizations in landscapes that demand a high level of security, so this could include banking, finance, and insurance, it can be difficult to reconcile the essential development needs with governance, management, and security before, during, and after deployment. It's a very, very complex process and is requiring a lot of different moving parts. In fact, 61% of organizations that were surveyed in a recent Cisco report identified that their organizations have experienced an increase in cyber threats during the pandemic. This makes sense. A lot of people are working from home now, and that obviously adds an additional layer of challenges. And one of the clear reasons in this growth is new technologies and devices. the complex Internet of Things functioning within business networks is creating an expanded attack surface. If you've attended previous webinars, you'll have learned about the broadening attack landscape that is creating a challenge for business leaders. And that's also a great plug to go back and watch some of the on-demand content if you have missed out on that so far. For a while, application security testing has primarily been a nice to have. A simple addition to the software development process that provides value to the development cycle and protects the strength of applications. But with the developing threat level, it has become an essential. In addition, the implementation of application security testing into the actual SDLC will help to mitigate the challenges of attempting to remediate vulnerabilities after the fact. But with that said, let's dive into the top application security trends that we are identifying through 2021 so far. Development teams are releasing more frequently. Applications are constantly evolving, and it's essential for development organizations to be able to push forward and build more advanced apps that constantly provide more value and increase the engagement for their customers. We're not satisfied just having some engagement. We want our customers to be active, to return, and to stay viable for us as prospects. Web app exploits are the most common form of attack. Web apps are commonly used by most businesses, especially those in banking, finance, and the insurance space. Customer-facing clients are enabling end customers to enter their secure data into the web portals. But obviously, secure data being the indicative element there, it's essential for businesses to secure these applications so that customers can use them safely, securely, and confidently. Bot attacks have also expanded to target applications further. Bots are everywhere. They're increasing the challenges faced by development teams and increasing the pressure on security teams to prevent them. Without an automated approach and some form of application shielding, it can be tough for applications to stay resilient to that. Improperly secured APIs are a prime target for attackers now. APIs are absolutely essential, and there's simply no shortcut for a robust API security. An API-first approach to application development enables more personalized methods to interact with your customers, and they also provide new revenue streams and can increase speed to market. But the use of APIs also expands your attack surface even further, increasing your risk even more. As you can see, there are a myriad of issues that businesses are facing as they seek to develop their position in their marketplaces. But the truth is, end-to-end application security is also a business enabler. Application security is constantly perceived through the lens of prevention of challenges, prevention of cost, prevention of additional work, and really centered on the problems that already exist within the market, as we highlighted earlier. But there's a much wider lens that sort of needs to be used here. One that actually works to highlight the genuine benefits of application security for organizations from a proactive standpoint. So let's ask a deeper question. Outside of risk management optimization, how is the value of security demonstrated? Well, the first one is an increase in operational efficiency. Development teams are always so focused on increasing their operational efficiency, whether it's implementing an agile development approach or changing the way that their SDLC operates. It's essential to innovate and to drive increased efficiency within these development cycles so you can improve your time to market and everything like that. But adding security into the SDLC as well as after the fact within deployment allows development teams to speed up the process and remove any key blockers from a security perspective. It's also essential to assure digital trust. One of the biggest aspects of value empowered by securely developed assets is the additional benefit of digital trust. By implementing a proven security approach, you're providing validation to the strength and security of your applications and enshrining trust for your end user, which ultimately develops confidence in your brand and assures that positive brand affinity that we're all searching for. Next would be taking a proactive security approach. So implementing security into your development and deployment approach helps to avoid the risk of attacks that will arise down the line. Having a proactive security approach allows businesses to mitigate the problems that will arise from poorly built and deployed apps down the line. Acting before there are issues can save you time, money, and stress. I think we all know that. And the final point is the competitive advantage that you can access from implementing application security. With everything being so interconnected, and the increased leveraging of the Internet of Things and business applications. We're really seeing a significant growth in the challenges that companies are facing whenever they're developing. And businesses can gain a competitive advantage from application security. The ability to protect their brand image, reduce risk, and protect customer data is an essential opportunity to drive a more effective competitive strength in their operations. So with all that noted, it is essential that businesses look to build an end-to-end approach for their application security, implementing a solution that enables security in collaboration with development and leveraging tools that keep applications secure even after deployment. Today, we're going to show you how end-to-end application security can give you a competitive advantage and allow you to secure your applications with confidence. So for that exact purpose, we're joined today by JD Burke from Kiuwan and John Brunner from PreEmptive, to take you through a full test case and really show you the value of the offering that we're presenting to you today and how this can help to really simplify your security approach. So without any further ado, I'm going to hand over to JD here, and he's actually going to take us through a full demonstration of this specific test case and help you to understand the value that can be provided here. So go ahead, JD.
Thank you, Alex. So as everybody saw on some of the previous slides there, John is the smart one, I'm the good looking one. And if I did this right, you should be seeing my Kiuwan screen. And what I'm showing you here is Kiuwan. Kiuwan is a SaaS, a cloud-based SaaS and SCA product. So actually we are an ISO 25000 code quality scanner that also does SCA, software composition analysis. That's third-party and open source scanning. We call it Insights, and SAST, code security. This is not a demonstration on how Kiuwan works. I will use it to scan some code, but if you have an interest in seeing more about how Kiuwan works, then you can follow the links that Alex has been sending you, and you can find us and we can get geeked up in some other call. So SAST, or code security in our world, is static application security testing. And what we've done here is that I have an application that we're scanning today. I have it loaded. I pulled a branch and loaded it onto my hard drive, into my laptop. And then what I'll do is I'll do a scan so you can see what's going on here and show you some of the results. I can tell you already that this, from my initial scan of that app, this app has about 34 vulnerabilities. And if you wanted to, you could step down and you could look at the vulnerabilities in more detail. And we'll talk about how this is common with all SAST tools, and kind of explore the ramifications of what that means. So let's, if we go back to what Alex was saying, folks like me, the SAST scanners of the world, help increase your operational efficiency. And then Alex talked about being proactive, taking a proactive security approach. And this is what we're talking about today, is that by most of the SAST and SCA tools that you'll have access to, and in our case, the code quality tool, will allow you to stitch into your pipeline. And you can build automated tools to scan codes on a pull request or whatever. In our case today, we're running the Kiuwan local analyzer. So that is Kiuwan, when we scan your code, we actually have a Java application that we, hold on a minute, let me pull this over here so you can see this. We have a Java application that you can run either in headless mode and stitch it into your pipeline, or a headed mode. And I'm going to be running it in a headed mode so you can see what we're doing. And what that does is once you log in, it checks into, if I can get my screens arranged here. It checks into the Kiuwan cloud account and it pulls down a list of the applications that I have added to my account or that I have been scanning. And in my particular case, we loaded up an app. So I pulled a branch, and then with Kiuwan, it's as simple as just selecting the app, selecting the folder where the app resides, and then perhaps you're going to decorate the scan or whatever. Click through, and then you get a chance to select whether you want to do SAST, code quality, or SCA, and then you can click through and analyze. So while this is analyzing, what's going to happen is that we will generate a new scan result, and we will populate Kiuwan with the vulnerabilities that we found. And I told you that all SAST, so all of our competitors, we happen to think Kiuwan's the greatest thing since sliced bread, but your mileage may vary. But all of us will produce a list of vulnerabilities, and we all suffer from the same problem, is that we tend to be fairly noisy. We find a lot of issues for you to work on. And Kiuwan maintains that it is true and correct that you should fix every one of these things because they're important to fix. They're things that we found in your code that were described by these normative standards that are bad or dangerous or risky, and you should mitigate those. Now the question becomes not so much if you should fix these, but when, because you have a day job, you have to balance priorities, you have to manage deliverables in a sprint, and you'll see later on that there may be other ways to, more cost-effective ways to solve these problems than just digging around in the code. But while we were talking, we did a scan. The scan finished. Let's see if it's posted yet. I haven't seen the email yet from Kiuwan. Normally Kiuwan will email me and tell me that there is a new analysis. So let's see if it's posted yet. So it's posted. So now I can see that I have 34 vulnerabilities in there. And the idea here would be that you would come to a list of vulnerabilities, you would adjudicate those vulnerabilities, mark whichever ones are muted or going to be handled in some other tool, or do whatever engineering analysis you need to do to figure out what's going to be worked on next. And then you would do like I'm going to do, and you would open up an IDE. I happen to use, I pulled up Visual Studio here, and I happen to have the plugin, the Kiuwan plugin. So Kiuwan makes a free plugin for some of the major IDEs, and you can download the results of the scan. So for example, if you spent some time here, you would see that this list of defects and the details about these defects are very similar to what you saw on the web dashboard for this. And then from here, I can, I have some amount of, I have my source code opened up in the project panel, but I can come to the defect list. I can look at a given defect that's been provided by Kiuwan. If I want to read more about it, I can. And then in this particular case, I just went ahead and clicked on that, and I opened up the project and went right to that file, went right to that line item that had the issues. So this code block is what's causing the problems. And I can click into here. And if you happen to not understand what this says, you can come back up to the dashboard. You can find the entry in here, and then you can read more about what that defect is, and then hopefully generate a teachable moment for yourself and learn how to fix this code. But in this case, what it's saying is good. So if I wanted to come over here, specifically what this is saying is that having writing these kind of lines and a do nothing kind of thing is not good. So perhaps I'll come in here and I'll go ahead and fix this code. And I make some kind of code fix to my code base. I go ahead and save my file or commit or whatever you do. And then I'm back to wanting to scan again. So I can go back over here to my Kiuwan local analyzer. I'm still set. And I can run my scan. And just like before, go ahead and process my scan. So now it's running. And when this completes, what I'll see is, let's move over here so I can see when it completes. We'll see a new scan in our scan list, and we'll be able to step through the improvement in our vulnerabilities. We'll see any increase in lines of code. We'll see changes to that code base. In this particular case, Kiuwan assigns a time budget for every vulnerability. So I have some sort of order of magnitude of what it would take to retire any one given quadrant. So I can use that to help manage my workload. And let's see if I've posted yet here. Scan, you can see in the background the scan is done. Let's see if the website's posted it yet. There you go. So I go to the iFixit scan, and I see that actually the fix I put in introduced vulnerabilities. So then you would come over here and you could start to look through your vulnerabilities and adjudicate this list. And in our case, you can create a thing called an action plan and create more work. Create a work list that you can push out to a task tracker so that you can start to assign issues. So like I said, all SAST suffer from the same problem, that we're pretty noisy. And one of your tasks is going to be to step through this list of very important things to work on and figure out what is the best way to solve a given problem and when. So just because a problem is in the list doesn't mean that you need to fix it today. There could be other ways to handle or mitigate this risk. One of the ways you could do this is you could actually assign this out to a developer and have them go ahead and work on the code. And you know, you can either use our action plans or just tell your folks to go ahead and work on that. The other way you could do this, you know, if you have them work on this code, then without some premeditation, then you might get in the situation where I was in, where I actually fixed a thing and added more issues. Then another way you can do this is that you could look at any one of these given vulnerabilities, and perhaps you have compensating controls in the code so that this given issue is not really the issue. It does match a pattern, but there are compensating controls in the code that neutralize this or mute this issue. Another way might be to, you might have compensating controls in the network. So you might have a WAF or something like that, to where the best way to fix a given thing is to use hardware in your system or in your network. And then the last way is you might use code protection, application type protection schemes like John's going to talk to us about, where you take tools like the tools that John has and you can obfuscate the code, and that would make it more difficult for external threat actors to take advantage of a given vulnerability, and buy more time for the developers and the engineering team to analyze the given issue, develop an approach to solving the problem, and then putting that approach, that work order, into some coming sprint. So let's review. We were able to do a scan pretty quickly. We used the plugin in the IDE to find the vulnerability in the code and then work on that. Hopefully your developers are better than I am and they don't introduce new issues into the code. Then once you get a scan, you can step through the vulnerabilities and you can decide to remediate a given vulnerability. And depending on what your analysis ends up being, you might use tools that you already have in your network or other tools like Alex and John are going to show us. So with that, I'm going to go ahead and hand us back over to Alex. I got to make sure I'm handing you the right one, Alex. So hopefully I did that right.
Yes, I'm here now.
It's not easy being as smart as I am. So.
Thank you, JD. Yeah, that was great, JD. He showed us everything that the Kiuwan tool can do to help to remediate some of those vulnerabilities. Well, certainly not everything, as he mentioned. If you would like a full demo, we'll be presenting the information to go ahead and schedule that at the end of this event. But with that said, now we are going to look into the specific need for app shielding. And to do that, we're going to have John Brunner from PreEmptive to present to you guys and show you how to use PreEmptive.
All right, I have started screen sharing. So thank you, Alex. Thank you, JD. So JD has shown us how Kiuwan can help identify potential threats and vulnerabilities by scanning our source code from the source code perspective. And now we'll see how PreEmptive can help remediate certain of those vulnerabilities by shielding our app against reverse engineering. But for most of the major programming languages in use today, there are decompilers and/or disassemblers available. In addition, there are code formatters, debuggers, and other similar tools within the hacker's toolbox. Many of these tools are free, several are open source. And when deploying our app to any unsecured environment, be it cloud, desktop, device, browser, Raspberry Pi, this can be almost the equivalent of handing out our source code if we don't take the appropriate steps, such as application shielding. And in the hands of a hacker or perhaps an unscrupulous competitor, there's a number of horrible things that can be done with nothing more than the deployed binaries. So for this particular portion of the demo, I'd like to hone in on the stealing of intellectual property or trade secrets and bypassing software checks. So again, as we saw with JD scanning the code in the first portion of the demo, this is a fairly trivial code base, but if we had any sort of size to our production application, we would see a number of things that would be impossible to take action on in one or two sprints. So we need to fit in other ways to protect. And one of the best ways of doing that, as you mentioned, is one of the best and quickest ways is to enable some sort of plan against for reverse engineering, to defend against reverse engineering, I should say. So let's take a quick minute to see what our demo app actually does, the one we've been working with. So I'm going to go ahead and launch my ping utility. When I first launch my app, I'm forced to authenticate. Log in with my admin credentials. And then when I first launch the application after authenticating, I can set a host, an endpoint, pick my favorite endpoint here. And I can send a ping-t to this endpoint. I can chart and graph the responses. I could add additional hosts. I could do some more custom configurations to my host, load custom settings, save to disk. Utility-based application. So that's what our demo app does. Now, this demo app happens to be a .NET application, and I know that there are several decompiler tools available that can decompile a .NET app. In this case, I've downloaded a free tool called ILSpy. And I'm going to go ahead and load up the binaries for this application. Just load them up. All right, so I have my main executable. I see there's a couple of referenced DLLs also included in this distributable, so I'm just going to load them all up. And if I'm approaching this from the standpoint of a hacker and I want to just poke around and discover what this app does, I'm going to start with this ping DLL. I wonder if this has something to do with pinging. So you can see with the decompiler, it presents the code in a tree view fashion to me. So I can drill down namespace, class, method, field. I can see that this particular assembly, the contents of this assembly, I can see the different field names and properties if there were any, constructor. I could see a number of overloaded methods called ping. Looks like he's just overloading this here. And if I drill down into this particular version of the overloaded method, I see a bunch of logic within this method that, bingo, I've discovered the super secret algorithm for sending pings. And this happens to be the crux of our application. So if I'm trying to discover what the application does, I've basically uncovered that right here. Well, now let's jump over to the executable itself. So again, I'm presented with a tree view of the namespaces. I see classes, and just following convention and coding practice, I'm going to go to the main program. I'm going to go into the main method. I see, naturally, this being a WinForm application, I'm loading my main form. And then I see something called the main form load, which, again, all I'm doing is following the application's natural startup sequence. And then when I see the main form load, I see a call to a function called check login. Gee, I wonder what this does. And I wonder if I can bypass that. So this is how a hacker is thinking. So let me just push it a little bit further. I'm going to take this code. I'm going to see the bytecode representation here. There's, again, a free plugin called ReflexIL that allows me to manipulate the MSIL code. And I'm just going to go ahead and delete it out. And I'm going to save a patch version of this assembly. All right, so just by poking around, again, following the app's normal startup sequence, just following convention of how we code things in .NET, I pretty easily discovered a way to get at the software checks for this particular application. So in this case, my software check is a login screen, but it could be a license check, etc. So now when I launch this patched version of the executable, I see that I was no longer presented with the login screen, and I could use all the different features of this app. So I'm going to go ahead and send it my ping and gain all the functionality that I would normally be given if I had purchased this app legally. All right, so we've seen that with just a couple of clicks within a free tool, I've compromised this .NET application with only the distributables. Not only could I browse the source code, steal the IP, steal our super secret ping algorithm, but I actually took it a step further and modified the functionality to circumvent our login check. And again, this is a desktop application, but I would have similar considerations to make for apps that were, if I was deploying to cloud, device, browser, Raspberry Pi, you name it. All right, so obviously this is something we want to avoid. So to protect this application, I've installed Preemptive's Obfuscator for .NET. Quick brag, Preemptive started back in 1996, our first obfuscation product officially deployed for Java in 1998. And in 2003, we became Microsoft's official obfuscation partner. So we have a lightweight version of Obfuscator for .NET shipping inside Visual Studio since VS 2003. Obfuscator is cross-platform, so we can develop on Mac, run our builds on Ubuntu Linux. Obfuscator has command line interface, standalone GUI, MS build Obfuscator task, Obfuscate task, excuse me. But in order to prevent having to do any sort of custom build scripting, I'm going to go ahead and integrate directly into my Visual Studio project. All right, so on our Preemptive website, we publish a couple of lines of XML that I can go ahead and plug directly into my CS Proj. Go ahead and take these lines here. And I'm going to go to, I have the source code here. I'm going to go to the entry point for this application. So that's my executable. I'm going to edit my project file. And then right before my closing project tag, I'm going to paste these couple of lines that I've copied from the Preemptive website. And all these are doing is they're calling to our Dofuscator targets file to allow us to automatically integrate into our project. And again, this makes it much simpler for us. It saves us any post-build scripting and makes our lives much easier. So I'm going to go ahead. I've reloaded my project, and I'm going to go ahead and set a startup project and kick off a rebuild of the solution. This build is going to go pretty quick, but when as we look at our build, any release mode build, just by copying and pasting those lines, we will see Dofuscator will automatically apply protection to all the assembly files that are built by this solution. So copy paste a couple lines, automatically integrates. And you know, this is a Windows simple WinForm application, but would work the same if we're doing ASP.NET Core, building a Xamarin application for device, etc. All right, so our build is completed, and our first build will be we're given pretty general configurations. So we you know, we integrate with a number of different types of projects: desktop, mobile, web, etc. So we have pretty generic configurations for all projects just right out of the gate. But if I wanted to do any sort of configurations or customizations for my project, when the first Dofuscator build completes, I'm provided with a Dofuscator config XML. And if I wanted to tweak this to add or remove any certain features or functionality, I could either hand edit the XML, which is we fully publish the XML format, or to make it just a little bit easier on myself, I'm going to go ahead and load that XML file in the Dofuscator config editor. All right, so let me take a path here, open it up, and this just offers us a graphical representation of this XML here. So if I have a lot of control, I have full control over the obfuscation settings, full control over granularity. So for example, if I want to add or remove any of these assemblies from obfuscation, any of the individual transforms, I could drill down to an individual transformation and select by assembly, by module, namespace, class, method, field, property, delegate. I have control over all of this, all of these settings. If I don't feel like checking checkboxes, I could also write pattern rules. So again, following convention, I could make a pattern rule to exclude any of the form controls from renaming, as an example. So I have a lot of control over these settings. The one thing I do know I want to do for this project is add a tamper check. So what I'll do is I'll go down to the checks section, and I have a number of options: debugging check, shelf life check, rooting check, if this was going on device. But I'm most concerned about that tamper check because I don't want anybody to be able to modify this application after deploying. So once I deploy to the end user's machine, I don't want them to be able to modify. So in order to do that, I'll select the tamper check option, and there's two things I need to configure. First is, where do I want this to be triggered? So I'm going to have this trigger as part of my application startup sequence, but not necessarily right away, just so we can see how this works. So I'm going to have this triggered on the add host handler. So when somebody clicks add host, that's the first action anybody would do within the app. I'm going to verify, I'm going to run the tamper check and make sure that it's still a legit assembly. Then after configuring where to trigger this, and I could also add multiple places. So if I wanted this to trigger in multiple locations in the app's lifecycle, I could do that. And then I need to configure a response. So we provide a couple of out-of-the-box responses. So if somebody tampers with your app, you can just shut it down. You can throw a rando exception, just a random exception that'll throw off the scent, or we could hang the app, force the application to hang. If we don't like any of those options, and frankly, most of our customers do prefer something more custom, logging something, doing a call home, then we can do that by configuring a application notification sync. All this means is a Boolean method, field, property, method argument, or delegate that will be flipped to true in the event of a tamper situation. So I happen to have written my own validate assembly method that I want to be triggered in the event, I trigger to true in the event that that I have been tampered with. All right, and I just need the owner, so that would be the type, and that is also within the main form. So if somebody tampers with my app, trigger this validate assembly method to be true and do my custom response. So again, we see we have a lot of control over these features, adding assemblies, removing assemblies, adding features, removing features. We have a lot of granularity over these controls. As with any good cooking program, I have a few pre-prepared recipes for us to review. So let's just say with our first build, I've only enabled the tamper feature. Tamper is only enabled. So now I'm going to go ahead and launch this in my decompiler disassembler tool. And again, I have not applied any code obfuscation. I've only done my tamper. So, I'm our hacker. I'm following the app's startup sequence, the natural startup sequence. And with ease, I've discovered my check login function. So I'm going to go ahead and delete it out. I want to bypass the login, and I want to save out a patched version. And then I can launch the application as I normally did, but when I go to click that add host, I see that my custom dialog that I've written is triggered. So the application has been compromised and must exit. This could take the form of a dialog, logging a custom message, doing a call home, etc. So now my application will exit. In my second pre-prepared recipe, I've enabled I've kept the tamper checking enabled, but I've also layered on string encryption renaming and control flow. So if I take a look at my second version and I load my main executable, again, a couple of our depending DLLs, launch those in the UI tool. If I expand out the assemblies, I see the code obfuscation has been heavily applied to this particular application. Function names have been, the signatures, names of these functions have been scrambled. The logic within has been scrambled. If I see anything within double quotes, a literal string, that has had obfuscation applied as well. If I browse over to my ping DLL, where I had a clear view window into what the ping actually did. If I try and peek the overloaded method, again, I'll see nonsensical monikers for the items that were originally called, send ping, receive ping. All this code has been mangled in such a way that if I'm a hacker trying to, again, take advantage of certain vulnerabilities, it would be much harder for me to do. I will never say impossible, but it would be much, much harder. And if I did try and take advantage of these vulnerabilities and bypass the login or do anything of that nature, then I would be stopped by the tamper check. All right, and one final recipe I've prepared would be when I actually turned all the dials up to 11 and I added full obfuscation, what I've called in this one. And what I've actually done in this case is I'm crashing the decompiler. So the decompiler won't even load the assembly files that I included obfuscation. This nspring is third party, so I didn't add it. So in this case, I'm actually crashing the decompiler. Okay, equally as important the app needs to be able to launch and run exactly as it did before, which it does. So all the same functionality exists, and everything will work exactly as it did before. All right, so there you have it. We've seen how to shield our app against reverse engineering and tampering. We've embedded these protections directly into our application, so we don't need to ship any external hardware, software, libraries, keys, etc. And from here, I would take and add Obfuscator to my build automation, whether it's Jenkins, Azure DevOps, GitLab, Bitbucket, doesn't matter, we work with all of them. And then I would deploy how I normally deploy, MSI installer, App Store, click once, Wix installer, doesn't matter. We'll support all of them. All right, that about does it. Handing it back to you, Alex. Change presenter.
Thanks, John. I appreciate your thorough demonstration there. So that pretty much wraps everything up there. We've looked through the combined approach and the true value of the Kiuwan and preemptive solution. But it's really important to understand that this combination of tools gives your team the flexibility to secure applications in a way that makes sense for your business needs. And whether that's limited development resources, Kiuwan and preemptive give you the opportunity to remediate as much as it makes sense and let obfuscation handle the rest of the issues. So on the Kiuwan side of things, Kiuwan is an industry-leading platform that's designed to secure development operations at every stage of the pipeline. The platform leverages effective static application security testing and software composition analysis to identify vulnerabilities and provide targeted remediations that help you secure your code, providing 3 key attributes that you see listed here. So the first being complying with security standards. You can stay aligned with key security standards and scan your code using a set of 4,000 plus rules based on industry standards. And Kiuwan also supports all common programming languages to ensure complete application security. Kiuwan also integrates with your pipeline. It fits seamlessly into your CI toolchain to add application vulnerability scanning directly into your development cycle, allowing you to identify vulnerabilities early in the application lifecycle and easily remediate quickly. You can also manage open source risk and automate tracking of open source components used within your applications. You can discover if your application code is exposed to risk from known vulnerabilities, obsolete versions, and licensing issues. But the combined solution doesn't stop there. We also leverage the value provided by the preemptive tool. Preemptive hits the sweet spot between cost, convenience, and functionality. By helping your organization to protect and secure apps in an intelligent manner, the layered application hardening and shielding is directly infused into your .NET, Java, Android, and iOS applications. That means you have direct control over application risk, security, and regulation compliance. The platform requires a variety of features to support your AppSec approach, offering layered application protection, which applies a layered approach to binary code protection using obfuscation, encryption, root detection, shielding, and tamper-proofing to mitigate potential exploits. You can also embed into Visual Studio. Preemptive protection is subject to Microsoft regression tests, code audits, and security reviews. It's the only third-party technology to provide this level of integration and validation. And it's a truly cross-platform solution, supporting a range of technologies. Preemptive invests to ensure consistent provision of support for frameworks and platforms that are in demand from our customers. So if you're ready to secure out your applications from development to deployment, you can get in touch with any of this information on screen here. You can visit the Preemptive website, the Kiuwan website, or use either of these emails to get in touch with the sales team. And with that all said, we do have a few questions that came in during the course of the presentation. So I'm going to throw these out in the order that they came in and make sure that everyone gets all the answers that they need. So the first question, and I think this one's for JD, how is it different from other static code tools like SonarQube or Checkmarx?
Yeah, so how are we different than our competitors? One of the things is that some of those tools will be language limited. So when you're checking those things out, make sure you watch out for upcharges on languages. So they'll give you a starter pack kind of thing. Kiuwan gives you everything. If we know how to do a language, you know how to do it. The second thing is that we are an integrated tool that does code quality, ISO 25000 code quality, and code security, and SCA. Some of those tools that are mentioned don't do the wider menu of scanning. They'll do one thing and then send you off somewhere else to get the other stuff, which is fine. It's just, it means you have to go to 3 or 4 tools to get everything you need.
Good answer. Thanks for that, JD. So it looks like we have another question for John here. And the question is, do we need any sort of obfuscation for CPP?
No, not currently, no. Our focus is primarily on managed languages, so C#, J#, VB.NET, F#, Java, Kotlin, or JavaScript. So we do focus our checks and code obfuscation around those languages.
Okay.
But we do manage C++. If it is managed C++, then yes.
Perfect. And it looks like we also have another question in a similar vein. Can we expect any performance impact in a deployed application due to obfuscation on the compiled codes?
It is possible. As we saw in the webinar, we try and keep our defaults pretty general. So if I just ran with the defaults, I wouldn't see any performance degradation. In fact, it would probably be a little bit faster due to the minification of the fully qualified type names and that sort of stuff. So the memory footprint would be smaller. But if you do, say, turn the dials all the way to 11, as I did in the last demo, there would probably be some sort of a performance impact. So we always recommend doing benchmarking pre and post obfuscation to see where we're at. And then again, those dials can be really finely tuned. So if we can narrow it down to a specific method, then we could even do a different level of obfuscation on that particular method, knowing that that there's performance implications.
Great, makes sense. Thank you. Another question for JD. Is there any feature or any plan to highlight differences, deltas between scans, i.e. fixed or new vulnerabilities?
Yeah, so we already have features in there. I didn't show those on today's demo, but you can contact us for a demo. We can explore that. But yes, because we have memory and history, we can show you performance over time, and we can show you the changes between scans. So I could have drilled right down to the bug that I introduced if we wanted. And then in our roadmap, we have additional some features coming out to help connect the other scan interfaces. So that's SCA and code quality and integrate them together and more strongly. So it's easier for you to do that work load analysis. So that man-month type of analysis, so you can figure out what is my next best move, what's the smartest thing to fix next, and how to fix it.
Great, thanks for that. And then another question for John. Is there a way to map back to the original source from a stack trace?
Yeah, yes, absolutely. When Obfuscator does a build, it will produce a build artifact called a mapping XML, which will give class method field name, or excuse me, class and method names original and obfuscated. And then we also ship with a tool called Lucidator, which allows us to decode the stack traces to meaningful class method names and line numbers and source file names. So with those elements, we could pretty easily debug the obfuscated code.
Great. And I think this next question is in reference to what you were saying earlier, John. Do you also provide support for Swift and Objective-C?
Not currently, no. But we're always researching languages and platforms in the direction that we want to go. That is not something that we currently do. We do have an open source tool that we kind of put out there at one point for Objective-C. Yeah, so currently no, but it is something we're investigating for the future developments.
Okay, and based on that question, we also have another question that dives deeper into what languages are covered by both solutions. Perhaps you could start, John, and just give a quick overview of that, and then JD can follow up from the Kiuwan side.
Sure, yeah. So our focus is around the managed languages. So we started with Java all those years ago. So, and then continuing on to .NET and JavaScript. So nowadays it's more around platforms. So if you're doing any of the JavaScript platforms, React Native, React, Angular, etc., any of the JavaScript platforms will be supported. And in the .NET space, again, any .NET type, .NET Core, WPF will be supported. And then same with Java. So if you're doing native Android or anything with the Java Kotlin is also bytecode. So C#, F#, VB.NET, Java, Kotlin, managed C++, and JavaScript.
And for the Kiuwan side, everything that John said, except for F#. We don't currently have an F# parser engine. And then a bunch of stuff he did not say, like ABAP, COBOL, a bunch of the old stuff. So anybody who doesn't know what that is, you can Google it. It's the old stuff. We have some 36 languages, and I think it's 25 frameworks that we support. And those are changing all the time as new and cool things come out.
Great, thank you for that, JD. I guess keeping it with you, we have another question here. How are Kiuwan and PreEmptive connected?
Yeah, so John and I live in a pipeline, right? So currently, I'm over on the left-hand side of the pipeline, close to the product managers and the threat managers, threat analysts, and the developers. And then one of the things you saw, or I hinted at in the demo, was that when you detect a vulnerability with Kiuwan, you can assign it out to a task tracker like Jira, for example. And then the idea here is that if you have something that you develop on the left-hand side that you want to hand over to somebody on the right-hand side, like John, you would register that in your task tracker and then assign that as a task. And the idea here is that you have a human in the flow. So an engineering manager type can get together with an operations type, and they can say the best solution for this code issue we have is to have the operations type obfuscate this code. All right, so create a ticket to notify John that we have a code object that we're pushing that we would like him to obfuscate on the way out, and then he can pick up that ticket, or his system can pick up that ticket and then manually or automatically obfuscate that and on its way out to the production front. So generally speaking, in our scenario that we presented today, it's via old school ticketing systems. Now, what you did not see is that because we're in different areas, we both used via Visual Studio to manage our code. I loaded up the Kiuwan plugin, but not the PreEmptive plugin. So there are other ways you can do this if you're a smaller shop where it's all kind of done in one click, one stop kind of way. But the way we showed it today was more of a pipeline type thing where you go through Jira.
Perfect. Yeah, thank you, JD, for that answer, and thank you both for joining us today. And extending that to everyone that attended. We hope that you were able to get something out of this webinar. And if you do have any additional questions, if you'd like to learn more, if what you saw today was exciting to you and you'd like to schedule a full demo, that information is available right there on the screen. And you'll be helped right here by JD and John, and they'll be able to walk you through that whole process, show you everything you need to know about the application, and see if it's a good fit for your specific needs. But with that said, we're going to go ahead and wrap up. We have about 30 seconds left of this webinar. But thank you so much for joining. We'll be having another webinar shortly, so be sure to be on the lookout for that. And we will be emailing out the presentation as well as the recording. Make sure that you share that with others at your companies as well. Thank you so much. Goodbye.